This is Edexcel IGCSE, further PO 2017, paper 1, and that's all you got 2 hours. It's a calculator paper, and you'll need to use this quite a lot during the paper, especially towards the back end questions. So the roots of this equation are this, alpha and beta, and then find the equation that has roots 1 over alpha, 1 over beta. So it wants you to use the sum of roots and then the product of roots. So the sum of roots you should know is minus b over a. Okay, so we can say that alpha plus beta is minus b over here, minus b over a here, so that's minus 3 over 4. Get that? And the product of the roots is c over a, you should just know this, and c over a is minus 8 over 4, which is minus 2, so alpha beta equals minus 2. Okay, and now the sum of the roots of this new equation is 1 over alpha plus 1 over beta, which is that. You can just give them the same common denominator and then add them up to get this. We know what alpha and beta is. We know what alpha plus beta is. It's 3 over 4, and we know what alpha beta is. It's minus 2. So just plug those in. You'll get minus 3 over 8. And so the sum of the roots of the new equation will be minus 3 over 8. The product of the roots of the new equation will be 1 over alpha beta. Okay, and we know that alpha beta equals minus 2. So it's 1 over minus 2, which is just minus a half. If we say that, we'll just say for the new equation, let just a equal 1. So the coefficient of x squared will be 1. Okay, and we can say that minus b over a, which is the sum of the roots of the new equation, if this a is 1, minus b equals minus 3 over 8, therefore b equals 3 over 8. And then c over a, so the product of the roots of the new equation, is minus half, and if this equals 1, so c equals minus half. So the new equation is this, and then just multiply by a on both sides to get this, and that's it. Find the set of values of p for which the equation, this has 2 distinct real roots, so the discriminant is going to be greater than 0. The discriminant is b squared minus 4ac. Just plug this in. So b is going to be p minus 1, a is 2, c is minus 2p. Just plug that in, expand this as p squared minus 2p plus 1, and then this is minus a, but then plus 16p. Oh, is it? Oh, no, sorry. Yeah, it should. Sorry, I had to correct that because that should not have said 32. It should have said plus 16. Plus 16p, so this is p squared plus 14p plus 1. It's greater than 0. You can put this into a quadratic formula or just, you can't even factorize that. Yeah, just put it into a quadratic formula. You'll get this and you'll get that. If you just have a look, so it needs to be greater than 0. So you're going to want anything that's bigger than this and anything that's less than that. So it's that or that. Okay. The area is 16.8 and the perimeter is 16.4. This is in radians. So half r squared theta, which is the area, will be 16.8. And then we've got r here. So that's 2r plus r theta, which is the arc length here, equals 16.4. Rearrange for theta, put that into there to get that, and then just expand and then rearrange for r squared. Oh no, sorry, this is quadratic. This is a quadratic equation. So just get it in this form. You can multiply by 10 on both sides, but if you notice, if you multiply it by 10, everything here will be even. So instead of multiplying by 10, you can multiply by 5 to get this. The way that I would factorize this is I would bring this and multiply it by that and just make this equal to a 1. You could just put it into a quadratic formula and just not listen to the rest of what I have to say because this is a calculator paper. So 5 multiplied by that to get this, and then just factorize this and then divide by 5 here. Simplify it as much as possible. If it doesn't simplify, then you can just bring the denominator in front of the r, like that. So r equals 21 over 5 or r equals 4. And r cannot equal 21 over 5. You can just plug it back in and just realize that it just won't. It also tells us here that r is an integer, so it can't be this. R equals 4. The value of theta, okay, well, that's fine. So we can say that we already know that theta r plus 2r equals 16.5. We know what r is. Plug it in, just rearrange for theta to get 2.1. Okay, show that dy by dx equals this. We'll call this top one here f of x, and we'll call the bottom, this bottom part here g of x. And this is the quotient rule that you get given in the formula booklet. So we'll say f of x equals sine of 2x, and then we'll differentiate that. So we want f prime of x, which is going to be 2 cosine 2x, because you differentiate the outside, leave the inside the same, and then differentiate the inside, leave the outside the same to get this. G of x will do the same thing. So this here is g of x. We're going to differentiate the outside, and then leave the inside the same, and then differentiate the inside, leave the outside the same. So this is going to be half x squared minus 9 multiplied by 2x, because the derivative of the inside is just 2x. To get that, this 2 and that 2 cancels, because, sorry, the 2 and that half cancels, so this just becomes x multiplied by this. Yeah, obviously this is just the same thing here, because negative power is just the reciprocal. You'll get this. We've got f of x, we've got g of x. Now you can just start plugging it into this formula. This looks pretty weird, but I mean, it's fine. Here, what do you have? So we can say that, what have I actually done here? This is just so much working out. Okay, well, apparently I've just not changed a single thing between those two. What I'm going to do is I'm going to multiply this one by x squared minus 9 over x squared minus 9 to get that. And then just go to this next page. Then I'm going to factorize 1 over root x squared minus 9 from this top here to get this. And then what else can we say? We can say that, okay, so if we multiply these two out, this is all to the power of a half plus to the power of 1. So this is to the power of 3 over 2. The top is fine, actually. We don't even need to change it. This is obviously the square root of this cubed. And that's it. Solve this equation. If you notice here, we've got a different base. So you can use this formula here that you get given in the booklet. It's the change of base formula. And we're just going to be using that to give them the same base. You can pick whatever base you want. It really doesn't matter. Looks like I've gone with base 3. You can just, you can just plug it in. So this is what you want. Sorry, B is what you want, and then A is just the original base. This is base 3, and then I'll put it all into base 9. Anyways, yeah, you get that. You get log base 3 of root x minus 5. So this part here, I'm going to change this, is 2 log base 9 of root x minus 5. And now I'm going to replace this here with that here to get this. And then I'm going to do, oh, well, actually, because these, if you just use your log rules, you can multiply the inside here because you're just adding logs of the same base. You'll get this. This is x squared minus 2x minus 15. Raise everything to the power of 9. So you do 9 to the power of this, and then 9 to the power of that. You'll get this. Subtract 9 from both sides to get that. Factorize that to get this. X equals 6, x equals minus 12. Except you can't do a log of a negative number. You can't do say a log of negative x. So you can just say that x equals 6 is the only solution. The volume of a sphere with increasing with radius r is increasing at a constant rate of 3 centimeters cubed per second. We need the volume and we need surface area. The volume is this, and the surface area. Oh no, sorry, I've not written the surface area. If you differentiate this, you'll get that. This is interestingly also the surface area, but this is also it. So we've got the volume here, we've got the surface area. This is the rate at which the surface area is changing with respect to the radius, and we know that. What is it? Where have I done? And then if we differentiate this, this is the rate at which the surface area is changing with respect to the radius, and we know that the rate here, which is dA over dt with respect to time, is 3. Okay, so if we say that this is dv over dt, sorry, I meant to say the volume with respect to time. So dv over dt, which we already know is 3, and then we've got dr over dv, which is just the reciprocal of this, and then we've got dA over dr, which is just 8 pi r. And the reason why I've done this is because if you notice, this dr cancels, and then this dv cancels, so you get dA over dt. And because obviously that's because we want the surface area changing with respect to time. We want the rate at which the surface area is changing. Okay, so we'll just plug this in. We know this, we know this, we know that. Plug it in to get that. Just simplify to get this. This is, the pi's cancel, r's cancel, and then this is 6. So 6 over r. We've got when r equals 10, so it's just 6 over 10, which is 0.6. centimeters squared per second. We've got a triangle here. We've got these lengths on, and we need to show that cosine theta equals that. The cosine rule, or Al-Kashi's rule, is this. I don't know if this is given in the form. Oh wait, yes, it is given in the formula booklet. So you don't even need to remember it. Just rearrange for cosine A. I'm sure you can do that, and then just plug in the values for A, B, and C. So if you call this A, and then this is B, this is C, or this is C, this is B, or this is C, this is B, it makes no difference. But this one has to be A. Plug it in to get that, and then just simplify a bit more, and then a little bit more to get that, and more to get that, and then just swap these two around, and that's fine. The area of triangle ABC is root 455. Find two possible values of k. So we can use half AB sine C, and that equals root 455. This is 3 multiplied by 8, which is 24 sine theta. Divide by 24, so you have sine theta equals that. Right, I'm going to try to get cosine theta, because we've already got this in terms of cosine theta. So yeah, we'll just do that, because then I can just plug this into there, and then we can solve for k. You can use one of the Pythagorean identities, which is sine squared theta plus cosine squared theta is identical to 1. I know it says equal here, but I couldn't find the identity button. But yeah, that's identical to 1. So if we square both sides of this to get sine squared equals 455 over 24 squared, and then we plug it into there and then rearrange for cosine. So we do cosine squared theta subtract equals 1 minus sine squared theta, and then square root all of that to get this. This is plus or minus. Plug this into there to get that. We've already squared this last time. Anyways, you get that. Have I plugged? Okay, never mind. I've just rearranged this one here for k, and then I'm going to plug this into there to get that. You can just put this all into a calculator, because you do have one. You get k squared equals 144, and k squared equals 56. So k equals 12, or k equals root 56. You can actually simplify that, but you don't need to. Okay, so find B in terms of A and B. So I've already drawn on like this triangle here. I don't think I actually meant to put that early. It doesn't really matter. So find B. So this is just A plus B, and then find BC as a simplified expression. So BC here, this is a bit more difficult, but one way that you can think of it is this here is B. Okay, and if we call all of these lengths 1, it doesn't matter what we call them, but if we just pick 1, it's the length is 1. That'll be like best, because it's easier to work with just with 1. You can pick 10 or 100 or a million, it doesn't matter, but I'm just going to pick 1. And if we do, and you have a look at this, so to get BC, yeah, that's BC that we want, we can just find what OC is, and then we'll use that later on to find BC. And you can find OC because it's just this here, this length here, which is the same as this length here, plus B. Okay, and then yeah, okay, so we'll do that. This here is going to be 30 degrees. You can use n minus 2 multiplied by 180 divided by n to get what the interior angle is of a polygon, where n is equal to 6, because it's a hexagon. You'll get 30 degrees as well. Okay, and we can say that sine of 30 degrees equals x, and we'll call this length here x, so opposite over hypotenuse. So x over 1 is just x, so sine of 30 degrees equals x, x equals a half. Okay, we've got a half here, and a half here, and this length here, which is 1. So that a half plus 1 plus a half is 2. And we can say that OC is 2B. Okay, we can say that BC is BO plus OC. Okay, we know what BO is. It's minus B minus A, and then OC is 2B. You'll get that. Simplified to get that. The point M divides BC in the ratio 2 to 1. So, where is it? Oh, sorry. Okay, so BM is 2/3 of BC. Okay, and then we know that BC is B minus A. we can say that OM, so O is, where is O? Okay, so OM is, yeah, so we can say that OM is OB plus BM. Okay, so OB, so we're going up this way, and then here. We know what OB is, it's just A plus B, and then BM is this. So just add them together, simplify, you get that. Okay, the point Y is such that OMY, OMY. So the point Y is just extended out to like here somewhere, and then ABY is a straight line. Let me see if I drawn this on. Okay, I forgot to edit all of that apparently, but okay, so I just removed all of that and actually animated it properly just really quickly. Yeah, so this is the point here Y, and then this triangle here is made. This is an angle of what is it, 150 degrees, I think. But anyways, we can say that OY is just some multiple of OM, and we know what OM is. It's this, okay? So if we extend OM by some scalar multiple, what have I picked? K, then you'll get OY, okay? So we'll just say that. We'll say OY is this, okay? We can also say that OY is OA plus some scalar multiple of B here, because it's the length, it's the vector here AB extended out by some other scalar multiple, and then we'll call that lambda. Usually use K and lambda, but you can call them whatever you want. Okay, so we can say it's A plus lambda B. Okay, and these two are the exact same because they get us to the same place. Okay, so you can set them equal to each other and expand. You'll get that, and then we'll equate coefficients. So what equating coefficients means is just looking at the coefficient or the numbers next to whatever you're looking for. So if we equate coefficients by looking at A, so we have what's around A basically. So we have a third K equals 1, okay, because the coefficient here is just 1. So K equals 3. Now we're looking at B, so we have 5/3 K equals lambda. Okay, we know what K is, it's 3, so lambda equals 5. And we know that 5 multiplied by AB plus this A here gives us OY. You can just plug it back into anyone to get what OY is. Do we even need that? Yeah, okay. So we can, yeah, so I plugged it into this one here. So this from O to Y will be A plus 5B, and then AY will just be 5B. Okay. BY is just AY take away AB. We know what AY is, we know what AB is. AB is B, and AY is 5B, so 5B take away B is just 4B. And yeah, that's fine. So we can say that the ratio is B to 4B, because we want the ratio of AB, BY. So this is B, this is 4B, so B to 4B is just 1 to 4, and that's the answer. The area of hexagon OABCDE. So OABCDE. So this hexagon here has an area of 60. Find the area of triangle OAY. Okay, so if we call this length here 4x, okay, and we'll call this length here x, because this was 1 originally, and then this is 4 multiplied by 1, because if you remember we said we just let one side equal 1, but now we'll call it x because we actually need to find an area. So if this is x, this is going to be 4x. That means this is x, 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 x. These are all x's around the outside, and we can say that what's it, half AB sine C of this triangle here. Oh yeah, sorry, and then this angle here would be 120, not 150. So half AB sine C of this, so you have half x multiplied by 5x sine of 120 gives us this triangle's area. You get that. For some reason I'm not expanding that, it doesn't really matter. But if we have a look at the area of this now, we've got 6 equilateral triangles of the area of this hexagon. We've got this one here, and then another one here, another one here, another one here. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Sorry. So you have 6 there. So if we find the area of this one triangle here and multiply it by 6, we'll get the area of this. Then we can equate that to 60. The area of an equilateral triangle, because these are all equilateral triangles, is s squared root 3 over 4, where s is the length of one of the sides. If you didn't know this, you could just do this normally here, so you could just use half AB sine C again, and that'd be fine. So this would be x, that'd be x, half AB sine C. You'd get the exact same thing, and then we'll multiply this by 6. So we have 6 lots of the length of one side, x, and then square it, x squared root 3 over 4. So this is the area of one triangle, multiply it by 6. You'll get that, simplify it to this, and that equals 60. Multiply by 2, divide by 3 root 3 to get what x equals. So that's 4, square root of 40 over root 3. You could rationalize this, but I've just written it in decimal form. You've got a calculator, so you can just do this very quickly. Plug this into there to get what a equals. Expand, you'll get 50 units squared, or 50 square units. Show that this equals that. What this is it's basically just adding up everything from r equals 1 to n. So if we just write out the first few terms, you've also got this formula here that we'll look to later. If you just write out the first few terms, you've got 4, 9, 14, 19, because if you plug in r equals 1, and then r equals 2, r equals 3, r equals 4, so you have 5 minus 1 is 4, and then 10 minus 1, and then 15 minus 1, and 20 minus 1. Okay, and this is just this. These two are basically the exact same thing, but this just goes on to n, and ours just goes on to 4. So we can sum them together. We know that n is just n, but we have a, which is the first term, which is 4, and then we have the difference. There's a difference of 5 between each of these. Just plug it into that formula. You just rearrange and expand. You'll get this, and that's the same as that. Hence or otherwise evaluate this. What you could do is just find out what it is from 20 to 0, because all the formulas that we have for it go from 0 to whatever n is. So this is 0 to n. What you could do is find out what 0 to 20 is, and then find out what 0 to 9 is, and then just from what 1 to 20 is, and then what 1 to 9 is, and then you just subtract them. And I'll show what I mean by that. So we've got this, okay, and we want to find the sum of the first n20, where n is 20. So just plug in 20, and you'll get 1030. So if you sum from 1 to 20, you'll get 1020. We don't want 1 to 20 though, we want 10 to 20. So if we find out what the sum is from 1 to 9, which is going to be where n equals 9, so we just plug it into this equation here, and then just expand, you get 216. So if from 1 to 20 is 1030, and then from 1 to 9 is 216, we can say that from 10 to 20 is going to be this minus that. You can stop for a second and just think about it if you need to. Subtract these two, you'll get 814. The sum of the first n terms of an arithmetic sequence is this. This is basically just repeating that. It means the same thing. The r term of this series is UR. Okay, so we've gotten this here. We've already gotten this from last time. And we're told that this equals Sn. Okay, so we'll just let it equal Sn. And we know that the first few terms is this. Okay, and the nth term of this is going to be 5n minus 1. Okay, it's just the difference between here, and then how do you get from here to there? So 5n minus 1. You can just use the formula. There is a formula. And we're saying that the rth term of this series, this new series is called UR, by the way, and the rth term of it is just when n equals r. So 5r minus 1. We're told that equals UR. Okay. This here is basically just telling us to substitute in r wherever the variable is, but we want n plus 1. Okay, so we can say, if we just replace the r here with n plus 1, you'll get that, and then we're told that equals un plus 1. Well, we know that equals un plus 1. Expand this as 5n minus 4. Sorry, 5n plus 4, I don't know why I said minus. And that's un plus 1 still. Now you can just plug everything into there. So you have this equals 12 lots of this plus 52. And then just expand and then rearrange. Yeah, sorry, I forgot to add the 52. And then just expand and then rearrange. So this is 60n plus 48. 48 plus 52 is 100. And then, sorry, oh no, 12 times 5 is 60, obviously. You get that. Multiply by 2, so you get 120 plus 200. 120n plus 200. And then this is 3n plus 50 plus 5n squared. Subtract 120 on both sides, so you get subtract 120 on both sides to get minus 117, and then this will just be minus 200 equals 0. This does factorize, or you could just put it into a calculator because you've got one. You'll get n equals minus 8 over 5 or n equals 25. You can't have a decimal position in a series, or even a negative one for that matter. You can just think about it kind of logically. I'm not going to be 0.8 into a series. I'll just be some whole number into it. So you can't say this is a solution, friend. So n equals just 25. Show that the coordinates of M are this. Okay. Where is M? So we've got this equation here. Okay. The y coordinate will definitely be 0. Okay. Just by looking at this. So if we've got this and we let y equals 0, we make y equals 0. And then just subtract a half on both sides to get sine 3x equals minus a half. Then just inverse sine on both sides to get 3x equals minus pi over 6. We don't want minus pi over 6 because, well, if we have minus pi over 6, we're just going to be on the left side of this on this graph, and we actually want to be in the positive region. Okay, so the solution that we actually want is pi plus pi over 6. So we don't want this solution here. We want 3x equals 7 pi over 6. Okay, and then divide by 3 on both sides to get 7 pi over 18 equals x. The y equals 0, obviously, so that part's there, it's done. And then you've got another solution here, 7 pi over 6, and then plus 2 pi. So you've got 11 pi over 6. Okay, sorry, not plus 2 pi. You do 2 pi minus that. Sorry, you'll get this other solution. These two are the exact same, makes no difference. And then divide by 3 to get 11 pi over 18, and that's the other solution where n is, and y obviously is still 0. The curve C has a maximum at the point A. Find the coordinates of point A. So if it has a maximum, it's going to be a stationary point. So if we've got this, and then we differentiate it, we'll have this is a constant, so it'll just go to 0, and then this is 3 cosine 3x. Okay, and it's a stationary point, so that equals 0. Divide by 3 on both sides to get this, and then just inverse cosine on both sides to get the, well, cosine of inverse cosine of 0 will just be pi over 2 if you just think about the graph. So you've got 3x equals pi over 2, and then x equals pi over 6 because you just divide by 3 on both sides. You could just you could differentiate twice to just make sure that this is a maximum. It will be a maximum just by looking at it, because if you imagine this and you imagine that, you can see that pi over 6 is less than the coordinates of M, and it's also greater than 0, so it's definitely going to be between here and here. So it's definitely not going to be, between here and here. So if it's between here and here, it has to be this maximum point here and not this minimum. So just plug this back into there, because this is the value of x that maximizes y. Plug it in, so this is just pi over 2. The sine of pi over 2 is just 1. And then 1 plus a half is 1.5, or 3 over 2. Find an equation of M. Find the equation of the tangent at M. Okay, so we just want the gradient here. We've got what the first differential is. It's this. And we know that, what is it? The x coordinate of M is this. So plug this into there to get that. This is going to be 7 pi over 6. Cosine of 7 pi over 6. You can just plug it into our calculator. Multiply by 3, you'll get minus 3 root 3 over 2. So this is the gradient. So we have y equals minus m, which is this, x plus c. Plug in x, plug in y. We know what x and y is. It's this and that. Plug in that, expand, and then just rearrange for c to get this. 21 over 36 is obviously 7 over 12 because you divide by 3 over 3. Well, you divide this by 3, divide that by 3. and then just plug this back into there to get that. And then we want to multiply by 12 and then add this x and subtract this because we want it in this weird form. You've got that, and that's it. The finite region shown shaded by figure 4 is bound by, this is just waffle, ignore this, it just wants this shaded area. Okay, so we want to find the integral from O to m, add the integral from m to n. You can't do it from 0 to n because this area here will be negative because it's below the x-axis, so it'll kind of just take away from this area here and just cancel it out. So what you could do is just find the absolute value of this area here. So we want this integral here plus the absolute value of this, because this inside here will be negative. Alternatively, you could just subtract because you'll have a minus minus, which would just be positive. Just integrate this, you'll get half x minus a third cosine 3x for both of them. And then you could just plug this into a calculator. Your calculator does all of this. It's like the freest 4 marks ever. You know, minus this integration bit kind of. But your calculator does all of this. I've not included the plus c because once you like evaluate this, the plus c will cancel with the minus c. So I've actually just not included c. It doesn't really matter. This here will be a negative, obviously still. So you could just, if you don't know how to do this, what you do is you just have all of this, right? You plug in 7 pi over 18 where there's x, and then you subtract it from the exact same thing, but where there's x, you plug in 0. And you do the same thing for this one, but just with these new limits. You get that. If you do that and just put it into a calculator, you'll get this plus the absolute value of this number here. This will be positive now, so you'll just get this plus that, which is 1.46 square units. Given that x minus 4 is a factor, and when it's divided by x plus 1, the remainder is 25, show that a equals 6. Just be careful here, this says f prime of x, so this is just the first differential. You want to integrate this, we'll do this later. But we're saying that if x minus 4 is a factor, f of 4 is going to be 0. Because you can imagine this, well, I'm sure you already knew that actually, I don't really need to explain it. But this next part here, you might not have known. So, if when it's divided by x plus 1, the remainder is 25, we can say that f of minus 1 is 25. Because if you think about when you're, like, factorizing something, it's going to be equal to 0, so the remainder is 0. Now, this is the same thing, but the remainder is 25. So when you've got x minus 4, when this here is divided, when f of x is divided by x minus 4, the remainder is 0. And then when this f of x is divided by x plus 1, the remainder is 25. I hope that makes sense. And then, yeah, so now we want f of x. So just integrate this, because if you integrate a derivative, you get just the function itself. You'll get this. So this is going to be a third ax cubed minus 7x squared minus 10x plus c. Just increase the power by 1, divide by the new power for each one. This is obviously x to the 0, so x to the 0 plus 1, and then just constant of integration, always add it on. F of 4, just plug it in, and then plug in f of minus 1 later. So if you plug in f of 4, you get this. Put this all into a calculator, and this also equals 0. Okay. I've multiplied by 3 as well, just because I don't want this this fraction here. You'll get this. Do the exact same thing with this, so plug in minus 1. You've got a calculator, but to be fair, you could just do this part in your head. You'll get that equals 25 multiplied by 3 on both sides to get this. You've got 3c and 3c in both of them, so you can just subtract this one here from that one to cancel the c's. And so 64a minus a, so that's 65a, minus 456 minus 9, you'll get this, so 65a minus 465 equals minus 75. 0 minus 75 is minus 75. Add 465 on both sides, divide by 65, so a equals 6. Hence use algebra to solve the equation f of x equals 0. So we've got f of x equals this here. We'll know what a equals, that's 6, and then we just need to find what c equals. We got this here last time. If you are doing this question alongside me, you'll just flip back to the page that you were doing this question on, and then just solve for C. We know what A equals, so plug that into there, and then just rearrange for C. I'm sure you can do it. You get 24. Plug this into there, and then plug this into here, sorry. You'll get that. We know that x minus 4 is a factor, so we can say that f of x is x minus 4 multiplied by some other polynomial. Okay? Well, quadratic actually. Okay, and this here will give us this same thing. You could just use synthetic division to get the same thing. I'm sure you know how to do this actually if you've done a lot of practice for these types of questions. But you can just do this and then equate coefficients. You can say that, well, we want to make an x cubed, and we've only got, the only way to make an x cubed here is to multiply by this and that, multiply by these two together. But that gives us ax cubed, and we want 2x cubed, so a must equal 2 for us to have this same thing. So a equals 2 here, and similarly, the only way to get 24 here is to have a minus 6 here, because a minus 4 multiplied by minus 6 gives us 24. That's the only way to get a constant term when you're expanding double brackets, by multiplying the last terms of each one. So c equals minus 6, a equals 2. And then similarly for b, this one's a little bit more tricky, but we want a minus 7 lot of x squared. So we can say that the only way to get x squared is to multiply this by that, or to multiply this by that. So bx squared minus 8x squared equals minus 7x squared. The x squareds cancel, so if you just look at the coefficients, you have b minus 8 equals minus 7, and then you plus 8 on both sides to get b equals 1. So you get this. This you can factorize it. I'm going to show again the way that I used to factorize it, and that's just by multiplying this by that and then making this equal 1. So you get this. This is x minus 3x plus 4. And then what you do now is you take these numbers here, whatever they are, and then you divide by whatever the coefficient of x squared originally was. So that's 2. And now this here, you simplify it as much as possible. And if it doesn't simplify for either one of them or both, you take the denominator and you bring it over here. So this becomes a 2 because that simplifies fully. And then this one's just still a fraction. So what you do is take the denominator and just bring it over here to get that. Okay, and then this is the same thing as that, so just, plug it in. Get this. So x equals 4, x equals 3 over 2, or x equals minus 2. And those are the 3 solutions, and that's it.